So our next few lessons focus on quadratics. And before we get started in this specific lesson, let's just review a couple of things that I promise you already know about quadratics. And that would be these two forms of a quadratic equation. So first of all, a quadratic is anything with an x squared in it. And these are all going to be parabolas. Okay, so like I said, we're going to be talking about quadratics for the next few lessons. Our focus is on parabolas. I can write an equation for a parabola in standard form, which looks like this. This is when it's all pretty, okay? It's all simplified and nice. Ax squared plus bx plus c. That's called standard form of a quadratic. Or I can write the equation in what's called vertex form. And vertex form is not simplified, but it's nice because you can tell what the vertex is, and you can also pull out a couple of other properties of the parabola just from the equation, okay? So what we're talking about today is the transition between these two things. So first of all, if I want to go from vertex form to standard form, that's actually pretty easy to do. I can do this by just simplifying. Okay, and when I say simplify, I mean do the math. All right, follow order of operations, but I can do FOIL on this parenthesis here, and then I can distribute the A, and then I can move the K to the other side, and voila, I'll look like this, okay? So going from vertex form to standard form is not a big deal. You have all the math skills that you need to be able to do that. To be able to go back the other way, there's actually two different ways we're going to do this, and today's lesson is going to focus on one of them. So today we're going to focus on a process called completing the square. Okay, and the goal of completing the square is to get this piece. Now the rest of this is all going to fall into place, but you'll notice that in vertex form you've got a squared binomial. All right, so this thing in parentheses here is called a binomial. It's got two terms, and it's being squared. And so the goal of completing the square is to take something like this and get it to a point where we can write it like this. And like I said, the A and the K are going to just kind of come out of that naturally. So that's what completing the square is all about, and that's what we're focusing on today, is being able to get standard form into quadratic form. All right, and the process is called completing the square. So we're going to start with some preliminaries. These first couple of problems here are just to get your brain taking the right steps to be able to do this process. So let's remember how to do FOIL. So take a second, why don't you pause the video if you're watching right now, and see if you can remember how to work out x plus 3 squared and x minus 5 squared. So remember, this is going to look like x plus 3 times x plus 3. And then really what we're doing is the distributive property. We're just doing it twice. So I'm going to distribute the x to both of these, and then I'm going to distribute the 3 to both of these. So when I distribute the x, I get x times x is x squared. X times 3 gives me 3x. 3 times x gives me 3x. And 3 times 3 gives me 9. And I can clean that up a little more by putting these middle terms together, so I end up with x squared plus 6x plus 9. Okay? If we try that same process for the x minus 5 squared, the only difference here is now we have a negative to work with, not a big deal. That's going to be x minus 5 times x minus 5. So we would end up with x times x is x squared. I'm going to get 2 minus 5x's, and negative 5 times negative 5 is going to give me a plus 25, leaving me with x squared minus 10x plus 25. Okay, so it's important for you to know that process to know how these numbers relate to these numbers. However, the goal of completing the square is to do the exact opposite of what you just did. The goal of completing the square is to take something that's written like this and turn it back into this, because you notice in that vertex form, you get this expression that looks like this, right? And so we want to be able to take this thing and turn it back into this binomial squared, okay? Now, to do that, we really have to look at the relationship between the numbers. And you'll notice that in both of these examples, this middle term is double whatever this was back here in the parentheses. So I had a 3 here, I have a 6 here. I have a minus 5 here. I have a minus 10 here. Okay, so if I refer, and I hesitate to put a letter on this because the letters aren't going to jive with what's up here. But if I just call this number like my star number, I know that this middle term here is always going to be 2 times that star number. It's always going to be double. And that comes from the fact that I end up with 2 of those terms when I do FOIL, right? It ends up there twice. And then this number on the end, this constant, is always that number times itself, or in other words, that star number being squared, okay? So that's the relationship you need to recognize, is that this number in the middle comes from doubling this number, and the number on the end comes from squaring that number. And so if I give you something like this, you should be able to turn it back into this by recognizing that pattern. So that's what I want you to try to do now. And again, I would recommend you pause the video and try that for these next 3 examples. Try to write them back in the form x plus or minus something squared, okay? Try to write them as something x plus or minus something squared. Like I said, pause the video, give it a try. So when I look at this first one, I see a 12 and a 36. So when I think about what would I have to double to get that minus 12, it would be a negative 6. And then I just want to verify that negative 6 squared would also give me 36. Yep, that works. So this thing here would be x minus 6 squared. That's a process called factoring, and you actually did this at the end of last year. You don't have to do a lot of complicated factoring to be able to do completing the square, basically what we just did, but recognizing that this is double the number that I'm looking for, and this is the square of the number that I'm looking for. So let's try it here. This is double the number that I'm looking for. This is the square of the number that I'm looking for. So using those 2 pieces of information, I can say this would be x plus 1 squared. And if you really wanted to check, you could FOIL these things out and they should turn into that. Okay, so now let's look at this next one though, because when I look at that middle term, I think my number should be a 7, right? But 7 squared does not give me 20. So this thing, as it's written right now, I can't put back into this form. Okay, this is going to give me some issues here. I can't write this as a binomial squared. That's because these 2 are what we call perfect square trinomials. And that just means we can write them as a square of some binomial. Okay, we can write them like something squared. Okay, this one I can't do that because the numbers don't fit together. They're not compatible like they were before. So here's what I want you to think about. And again, pause the video and think if you need to. If I were to leave this 14x here, but I were to use this magical math pen of mine to get rid of this 20 and turn it into something else, and I can make it be anything I want so that I can write it in this form, what number do you wish was right here? Well, remember, whatever number we want to be right there, the number that I want in my parentheses is going to be doubled here and squared here. So this is clearly double 7, right? This is 2 times 7. So if I took 7 and squared it, I really wish this was a 49. Now, if that was a 49, I could come along and say this was x plus 7 squared. Now, obviously, that's not what it was originally, and we know that in math, we don't get to just have a magical math pen, right, that we can just go through and cross off any number that we don't like. But this is going to get you thinking in the right direction, okay, that this is the goal of completing the square. This is what I mean when I say completing the square, is if you have something that's not a perfect square, how do you make it into something that's a perfect square so that we can write it like this? Okay, so let's get into the actual process now. So in our first example here, remember how a second ago I just came along and I just crossed that number out because I didn't like it? We know in math that we're not allowed to do that. But what I will do is move it out of the way. Okay, so the first thing I'm going to do is take that 29 and slide it off to the side by subtracting it. So now my equation looks like this. Y minus 29 equals x squared plus 10x. And then the goal is to take this space here and fill in the number that we wish was there so that we could write it as a perfect square. Okay, so think about what we did just a second ago with the 14 and the 49. Is we said, okay, what would I have to double to get 10? Let's take that number and square it. So if I was going to write that mathematically, I would say I'm taking the 10 and dividing it by 2 to get 5, right? And then I'm taking that 5 and squaring it, and that's what's going to go right here. Now, that's all fine and good. I like that plan, okay, because now this is a perfect square trinomial. But we know in math we're not allowed to just come along and add 25 to this side, right? I can't just make this a plus 25 without a consequence, right? So what I'm going to do to balance the fact that I added 25 on this side is I'm going to add 25 on this side as well. Okay, so now if I rewrite my equation on the left side here, I have y minus 29, but then plus 25. So if I balance that out, that becomes a y minus 4 equals. And then over here, remember, I want to think about how I would write this as a perfect square trinomial. Or I'm sorry, this is a perfect square trinomial. I want to think about how I would write it as something squared, a binomial squared. Okay? And now, because I put my magic number in there, that should work. So I should be able to write this as x plus 5 squared. Because remember, if I double the 5, I'll get the 10x. And if I square the 5, I'll get the 25. This number here is always going to match this number here. Okay, so if you go through this process every time, and you're going to see me do this over and over again, you don't even have to think about what should go there. It's always just the number that came up right here when I split that number in half, but before I squared it. Okay, and now I've got my quadratic written in vertex form, and everything I did here was a-okay math-wise. Okay, I didn't break any math rules. So let's try that same thing on the next one. I'm going to start by moving the 7, right? So minus 7 minus 7. That gives me y minus 7 equals x squared minus 6x. And again, my goal here is to fill something in here on the end so that I can make this a perfect square trinomial. Okay, this is where the completing the square terminology comes from, is I'm putting something here to complete the perfect square trinomial. So what would I want to go there? Well, let's take this minus 6 and divide it by 2, which gives me a negative 3. And then when I take that negative 3 and square it, I get positive 9. By the way, this number is always going to be positive because you're squaring to get there, right? So I'm allowed to do that plus 9 as long as I come over here to the left side and I do a plus 9 there as well. Okay, so you have to keep that in mind, that whatever you put over here, I'm also adding over here on the left. So now when I clean this all up, negative 7 plus 9 gives me a y plus 2. And x squared minus 6x plus 9, if I'm trying to write that as a perfect square, a binomial squared, it's going to be x minus 3. So x minus 3 squared. If I were to FOIL that out and double check it, it would give me x squared minus 6x plus 9. And that's my answer. So just to clarify, this is the answer that I'm looking for in these problems. Okay, so think for a second, what's different about the next two problems from what we just did? And I hope that what you're seeing is this 3 right here. These other ones didn't have a number in front of x squared. Now, I will remind you, you did do these type last year. Okay, it was brief and you may or may not remember it, and that's okay. But we did these last year. We saved this specifically for this year because this is a situation that is a little more complicated. It starts out the same. So let's start by moving the 11 out of the way and making this y minus 11 equals, now I'm going to pause before I write that next step, but okay, so on the right here, I'm now going to have 3x squared plus 6x, but I can't I can't complete the square with a 3 there, okay, because I can't write 3x squared as x plus or minus something squared. I can't write it in this form. So what I need to do is I need to slide this 3 out of the way, kind of the same way I slid the 11 out of the way, except I'm not moving it all the way over to the other side. I just want to put it out in front. I'm going to put it here with parentheses, and then I'm going to say what's left over. So if I take a 3 off of 3x squared, I'll be left with just x squared. That part's easy, okay? But then if I take the 3 out of the 6x, because I would have to divide both of them by 3, okay, if I'm following my math rules, that now is going to become a 2x. Okay, this again comes from the factoring stuff that we did at the end of last year. So this is called factoring out the 3. It's like the reverse distributive property. And I divided both of these numbers by 3 is really what I did, and just put the 3 out here. So if I distributed the 3 back in here, it would give me back 3x squared plus 6x. This is where I'm going to complete the square. This is where I'm going to come up with what magic number goes here. So same as before, let's take this 2 and go 2 divided by 2 gives me 1. I'm going to take that 1 and square it and put it right here. Here's the difference with this problem, is I just put a plus 1 here, but that plus 1 is in these parentheses with a 3 on the outside. So that 1 is not really just a 1, it's being multiplied by the 3, which means I really just added 3 to this right side. I didn't just add 1, I added 3 because I did 3 times 1. So when I go to balance that over on this left side, I need to add 3 instead of just 1. Okay, that's the complicated part about this, is remembering that, well, first of all, remembering to pull this number out in front, and then remembering that that number applies to this magic number that you put in here when you go to balance it on the other side. The rest of this is going to work out just the same as before. I'm going to simplify that left side. Oops. So negative 11 plus 3 leaves me with a negative 8. I'm going to leave the 3 sitting out front here. And then x squared plus 2x plus 1 should be able to be written as a binomial squared. Again, if you're struggling with what number goes in those parentheses, it's always this number right here. So this will be x plus 1 squared. And this 3 just sits out here. That 3 actually tells us some stuff about a parabola. We're not going to get into that so much today. But maybe you remember from last year that that 3 has some significance. But it is okay for it to just be sitting out front. And if you were to go through and FOIL this and simplify it and distribute and all that stuff, it should turn right back into this guy. Okay, so one more of these to try. Just like before, let's move the 87 out of the way. So I'm going to add 87 to the other side. Okay, that's going to leave me, and I'm going to move down a little bit here. Y plus 87 equals, now notice I've got this negative 2 here. Remember, I want to write that negative 2 on the outside of the parentheses, which means that I have to divide both of these terms by negative 2. So this one's just going to become an x squared, okay, because when I FOIL that, that's what I want it to turn back into. And then I have to think about taking that negative 2 out of the 28, dividing 28 by negative 2, and I get negative 14, okay. So again, notice that if I were to distribute the negative 2, I would get back to what I had originally. And this space here is where I'm completing the square. So take that negative 14, divide by 2, and I get negative 7. Take the negative 7 and square it, and that's going to give me a plus 49. But what we have to remember is that plus 49 is actually being multiplied by negative 2. So I'm not just adding a 49, I'm adding a 49 times negative 2, which is really a negative 98. Okay. So when I go to simplify my quadratic, here on the left side, plus 87 minus 98, I believe leaves me with a y minus 11. Got my negative 2. And then this is the part that can be written as a binomial squared. This should be x minus 7 squared. And if you're stuck on what number should go right there, it's sitting right there for you. And again, on these last two, these are my final answers. Okay, So I would recommend you stop the video at this point, give the first part of the homework a try, where you're just going through and doing the completing the square process and getting answers like these things that are starred right here. Once you're feeling good about that, come on back, try completing the square on this next example, and then pick up with the next video to talk about these pieces where we're actually going to use that equation to do something. We're going to use that equation to find the vertex and the zeros of the parabola. So far, all we've been doing is rearranging it, and that's definitely the harder piece. So like I said, I would suggest you go try the first part of the homework assignment and then come back and try this example and then pick up with the next video.